Let's talk about bug algorithms. Bug algorithms are an easy way to get into path planning. They illustrate some interesting topics about how to get robots to move, and they're fairly easy to implement. The first algorithm we'll talk about is inspired by nature and how a bug will find its way around an obstacle. Whenever the bug hits some obstacle, it just turns around and tries to get around the obstacle. At some point it has gotten to the other side and then it just continues on. This is the naive bug algorithm. The robot on the left, the big round green thing, needs to go to the goal on the right, which is the triangle. In the middle there's an obstacle, but initially the robot just goes towards the goal from its position Q start. At some point it hits the obstacle, so we create a hit point. The H stands for hit, and 1 is because it's the first obstacle we hit. Now the bug turns right and just follows the obstacle along until it can see its goal again, and then it leaves and goes towards the goal. This seems like a good idea, a good way to get around this obstacle. But in the case that the obstacle is turned the other way, the robot goes towards the goal and creates a hit point. Then it turns right, follows along until there's a free path from its where it is towards the goal. Remember, it can only sense when it hits something, but it can't really see its way to the goal, so it thinks there's a free path right now. What happens is that it just hits the obstacle again, creating a hit point number 2, and then of course continues on. So the simple bug algorithm isn't a perfect algorithm. Sometimes it just doesn't find its way. To remedy this, we can add a little memory to the algorithm so that it remembers where it came from. We'll call this algorithm the Bug1. The Bug1 algorithm goes all the way around each obstacle and finds the best place to leave the obstacle. And then it continues towards the goal. So what it does is that it moves towards the goal, as any bug algorithm will do, until it reaches either the goal or an obstacle. If it's the goal, then it exits. But if it's not the goal, it has encountered an obstacle, it follows the boundary of the obstacle until either it reaches the goal or it re-encounters the hit point. When it re-encounters the hit point, it has encircled the entire obstacle, and now the point is that it has visited all the points on the perimeter and it finds the leave point, QL, on the obstacle I. In the case that it's the first obstacle, it would be QLI, 1. And then it goes around the perimeter again to QL. When it comes to QL, it tries to go towards the goal. If it immediately cannot go towards the goal, then it's because there's no way to the goal and it says you can't reach the goal, and it exits. It looks something like this. So we have our robot needs to go to the goal. It finds an obstacle, creates a hit point. Then it encircles the entire object. And when it reaches the hit point again, it says, okay, I found the point that's closest to my goal. Then it goes there. And from there, it goes to the goal. This is a simulation in Weebots that shows a Tiago base that is using the Bug1 algorithm in order to navigate around this obstacle. As you can see, it's following along the boundary quite well and trying to reach the goal up there. But first it needs to traverse the entire perimeter. Now it's approaching the hit point that you can see with the little red dot, and as it encounters the hit point, it sets the leave point, the other red dot, at the closest point to the goal. So now it needs to go there. It's not perfect in following the boundary, but it will suffice. As you can see, it gets to the point and now it changes heading towards the goal, and it's there. The Bug1 algorithm seems a bit strange, as it encircles all the obstacles that it encounters, where in some cases it could just go towards the goal. This is what the Bug2 algorithm tries to take advantage of, and we'll see that in a later video.